welcome to my sixth video outlining my SAAS project. In today's video, I would like to discuss why I chose microservices instead of building a monolith. In the previous video, I walked you through solid principles and a few design patterns that I expect to use as I build out this project. I cover the 5 principles that form the solid acronym: single responsibility, open for extension and closed for modification, discuss substitution, interface segregation, and dependency injection, and their importance in building flexible and maintainable software. I've previously discussed the main-driven design and onion architecture and why I chose them for this project. So these principles don't just help us to write better code, they also influence how we structure our applications. A well-architected system isn't just about clean code, it's about how easily we can build, test, deploy, and scale it. This is where architectural decisions like monolith versus microservices come into play. So let's discuss what monolithic applications typically look like. For years, monolithic applications were the standard. Very simple to start with, easy to develop, everything's in one place. Many successful companies still use monoliths, but as systems grow, monolithic architectures introduce challenges. In large organizations, there could be several monolithic applications serving the business's needs. Deployments must be managed, teams must be managed, lengthy meetings generally eat into a team's development time as they must navigate it all, whilst ensuring that all the moving parts are deployed and working. But as businesses grow, managing monolithic applications becomes increasingly complex. Scaling gets harder, deployment slows down, teams start stepping on each other's toes. Let's take a closer look at how monoliths are structured and why these challenges arise. A monolith is a single unified application where all the business logic, database access, and user interfaces reside in one code base. It's for this reason that it is a widely used pattern. Initial development efforts are easier as we're just starting out. Deployments are initially simpler as there are fewer moving parts and complexity. Imagine though, Visual Studio solution with 100+ projects that contains an MVC application and its supporting libraries. Much of the functionality is built into the MVC site, and we may have several other sites as part of the solution. We may have added a service bus implementation along the way. This presents several problems. Everything's tightly coupled together. Company runs on one tech stack. Let's say we want to move part of the system to .NET 8 or experiment with a different front end. That's not happening. Everything must move together with Flow's innovation. Each of the libraries will likely use project references, making them difficult to package into a NuGet feed. Because everything is built as one system, adopting new technologies becomes difficult. Modifications in one area could have cascading effects across the code base, and eventually it becomes a maintenance nightmare. Scaling can also prove difficult and ultimately costly, as we scale the system with more resources than it needs. Because the entire application is a single unit, you can't just scale the parts that need it. If only one feature, say package logging, needs more resources, you still have to scale the entire monolith. This means wasted infrastructure costs and inefficient resource use. We'll probably use sessions to track state across the application, which again impacts scaling efforts, as we must cater for these resources. Another issue is deployment. Since everything is part of a single code base, even a small bug fix requires redeploying the entire application. One bad commit can delay a release for days while teams scramble to resolve conflicts. Over time, this creates a fear of deployments and leads to slower, risk-averse deployment. With everything tightly coupled, a failure in one module can bring down the entire system. A single bad database query in the package tracking feature can crash the entire application, taking down unrelated functionality like user management. And over time, a monolithic code base becomes a bottleneck. Scaling is inefficient, deployments are risky, failures impact the whole system, and development slows to a crawl. And that's why I chose microservices. They come with their own challenges, but they solve many of these pain points and unlock a level of flexibility and scalability that monoliths can struggle with. So let's look at how. Microservices is an architectural style that breaks an application into small, independent services that are independently deployable and loosely coupled. Typically, these are organized around business capabilities, and each service is owned by a single team. A single responsibility principle is nicely here. The service should have one reason for existing to change. So hopefully you're starting to see how the solid principles and domain-driven design start to fit with this architectural approach. And what I gain from this approach is I can scale parts of my system independently from the rest. If my package API is seeing high demand, I can scale up the hardware or scale out by adding further instances to help balance the load. I can do this without affecting my other microservices. This gives me flexibility, not only in my ability to scale the hardware, but in being able to choose the right tool for the job. I'm not locked into a single tech stack. I can use Node.js, Java, or Python. Again, modularity, as my platform involves different teams, can own different services without stepping on each other's toes, providing for a better development experience all around. And deployments will be faster and less risky, as I can deploy parts of the system independently from the rest. And then I gain resilience. If one service fails, the entire system doesn't go down along with it. And finally, you may remember that I want to stay up to date, and match fit in my career. I've spent the last 3+ years mainly working on legacy code bases. This will give me a real world application to maintain the knowledge I've accumulated over the years, try out some patterns of my own, so that I can use these confidently in my paid consulting work. As I mentioned in the previous video, the concierge management API is what I see as the engine behind this. I should be able to use this API to pivot into other facilities management areas and diversify away from residential. Monolith is akin to an oil tank, and it takes a long time to turn. I aim to be like a speedboat that can quickly turn when needed to target new industries and opportunities. Pardon me. However, microservices don't come without their own set of challenges. While we gain flexibility, scalability, and resilience, we now have a distributed system, introducing complexity that we need to manage. Unlike a monolith where everything is in one place, we now have multiple independent services running across different servers, databases, and environments. Keeping track of all these moving parts is critical. Service discovery and API gateways play a huge role in making this manageable. Service discovery ensures that services can find and communicate with each other dynamically, while an API gateway centralizes requests, managing authentication, rate limiting, and security. With microservices, I'm no longer deploying a single application, but multiple independent and interconnected services. And that's where automation and CI/CD pipelines come in. I've already set up Azure DevOps YAML pipelines to handle builds and deployments. These will be the subject of a future video. This approach, known as infrastructure as code, ensures that my deployments remain reliable and repeatable. Containerization is another key aspect. Technologies like Docker ensure that services run consistently across environments. But once you have multiple services running, monitoring and observability becomes critical. Unlike a monolith where logs are in one place, microservices require a centralized logging solution like application insights to track and diagnose issues across the system. So microservices solve a lot of problems, but they do introduce new ones. That's why careful planning is critical. Without proper management, they can become a nightmare. Service discovery, monitoring, and API gateways help us keep things under control and ensure the system remains scalable and resilient. For my SaaS platform, microservices made sense because of its scalability, flexibility, modularity. The back-end architecture is just one part of the story. What about the front end? In the next video, I'll dive into why I chose to build my user interface using micro front ends and how they complement this architecture. And if you're enjoying this series and want to see how all these pieces fit together to build a scalable SaaS platform, don't forget to subscribe. And let me know in the comments how you're approaching microservices in your own project. Be nice to hear some thoughts.